Example number 1. Use the guidelines to sketch the curve f of x equal to y equal to x over x squared minus 1. I factor the bottom, so it equal to x minus 1 and x plus 1 for x squared minus 1. So step number 1, we find the domain. We can see that we cannot take the value positive and negative 1 for the x. Step number 2, we find the intercept. So first of all, x-intercept, we will let y equal to 0. That means 2x squared. And then x minus 1, x plus 1 equal to 0. This is the fraction equal to 0, then the top have to be 0. It means that x equal to 0. Then we got the point 0, 0 is the x-intercept. To find the y-intercept, we will let x equal to 0. Then we plug in 0 into the function. And we got 2 times 0 squared. In the bottom is 0 minus 1. And we got the answer is 0. So the y-intercept is also 0. Step number 3, we will check to see if the function is odd or even. Now we put in -1, negative x into the input. So we will get 2 times negative x squared over negative x squared minus 1. So that will be 2x squared and then x squared minus 1 is equal to f of x. This means that the function f of x is even. So the graph or the curve is symmetric with respect to the y-axis. Step number 4. The next step, we will find the asymptote. So first of all, let's talking about the horizontal asymptote first. We take the limit and we want to make the limit of the function 2x squared minus 1 as x approach to infinity, positive infinity or negative infinity. I see that they're the same if I input positive or negative infinity because I see the square for both x, right? So we learn in section 3.4, we will divide both of them, top and bottom, by x squared. Then we will get 2 on the top. In the bottom, we get 1 over x squared. When x approaches to infinity, this part is 0. Then we will have 2 over 1. And 2 over 1 is 2. Then what can we say about the horizontal asymptote? Horizontal asymptote is y equal to. Now to find the vertical asymptote, we see that the denominator 0 if x equal to positive 1 and negative 1. The denominator equal to 0 when x equal plus minus 1. So that's why we will compute the limit when x approaches to 1 on the left side of the function f of x. And then we also compute the limit when x approaches to the right side of the function f of x. Okay, so what can you think about? So 1 negative. So what do you think about this number is like 1 on the left side, so you think like 0.9. And then 1 plus, so that means 1 on the right side, you think about 1.1. So you plug in 0.9. On the top will be positive. In the bottom will be 0.9 squared. 0.9 squared is still less than 1, so this will be negative. The answer will be infinity. and it will be negative infinity. If we have 1.1 plug in for the x, we will get positive, and then 1.1 square will be greater than 1. You check with the calculator, so it will be positive. Now we also have to compute the limit when x approaches to negative 1 on the left side and when x approaches to negative 1 on the right side of the function. Okay, what number do we need to think about? For negative 1 on the left side, we can think like negative 1.1, and for negative 1 on the right side, we can think like negative 0.9. Okay, now let's plug in. On the top will be positive anyway because it's square. In the bottom, negative 1.1 square will be more than 1, so it's positive. And for similarly in the bottom, for the x approach to negative 1 on the right side, plug in x for x equal negative 0.9. On the top is positive. For the bottom, we have negative 0.9 square. It will be less than 1, so minus 1 will be negative. So we got negative infinity. Okay, so from the first two information, we conclude that x equal to 1 is a vertical asymptote. For the last two information, we can say that x equal negative 1 is a vertical asymptote. Okay, so we just finished step number 4. Then continue step number 5. We will find the increasing decreasing interval. First of all, we take the first derivative. So g of x times f prime, so it will be 4x minus f of x 2x squared, and g prime is 2x. Then divided by x squared minus 1. We use quotient rule, right? Okay, so you're going to simplify this by yourself, distribute open parentheses and so on, and then you will get negative 4x. Okay, so f prime of x equal to 0 when you have negative 4x equal to 0. That means x equal to 0. Now we draw the number line from negative infinity to positive infinity for the 0 of f prime of x. This is f prime of x side, okay, the side. So for the top, we got 0. The 0 is the 0 on the top. And in the bottom, we got plus minus 1. So we're going to put negative 1, 0, 1. Now we're testing the point. Okay, so we will plug in the point. So we're going to have plus right here. And then minus right here. Okay, so it will be increasing. At negative 1 and 1 is undefined. Okay, so because its domain is exclude positive 1 and negative 1. So keep that in mind. So we have positive from the left side of 0 and negative from the right side of 0. So we say increase in here and decrease here. What can we say about the 0? This is the local max, right? Okay. So we will say the function f of x is increasing from negative infinity to negative 1 union negative 1 comma 0, and f of x is decreasing from 0 to 1 union 1 to infinity. Okay, and we can also find the local max. So local max is 0. When we plug in the 0 into the function, we will get 0. So far what do we got is 0 is the x-intercept, y-intercept, and also local max, right? Okay, so the next step, number 6, we find the f, the param, so that we can find the concave upward interval or concave downward interval. Now we use the quotient rule again. Oh, by the way, let's go back to f prime. It's a square right here, right? Okay, I forget that. So in the bottom will be to the 4th. It's a chi square. Okay, so this is the answer for our f prime. Now we take one more derivative. So we will get x squared minus 1 square times negative 4 plus 4x. We use the chain rule. So we got 2 because of the x squared. X squared minus 1 exponent is 1 because 2 minus 1. And then the u prime, so that will be 2x. We will factor out the x squared minus 1 because I saw the x squared minus 1 in the bottom. Okay, so x squared minus 1 is here and x squared minus 1 is here. So they are common. So what do we have is negative 4 x squared minus 1 left plus we will get 16x. 16x squared. So we can cancel the x squared minus 1 and the x squared minus 1. So we get x squared minus 1 to the 3rd power. And for the x squared, when we multiply, we will have negative 4x squared. Then we have 16. So positive 12x squared plus 4. Okay, so we can see that f the param is always positive for the top because the top is always positive. So f the param equal to 0 only is, this is always positive since 12x squared plus 4 is always positive. So in order for f the param to be positive, then the bottom have to be positive. So for the bottom to be positive, that means x squared minus 1 have to be positive. And then for f the param less than 0, when the bottom have to be negative. Okay, so let's solve for the inequality x squared minus 1. So the 0 for the x squared minus 1 is negative 1 and 1. And then we check in the point. So we test in the point 0, we will get negative. We test in the point negative 2, we will get positive. We test in the point positive 2, we get positive. So this is concave up when you see plus, and concave down. The inflection point is not negative 1 and 1 because the domain is all real number except negative 1 and 1. So we do not have the inflection point. So no inflection point. And we can answer concave up from negative infinity to negative 1, and from 1 to infinity, concave downward when we have negative 1 to 1. Okay, so we already have enough information. Now the last step, step number the A, the last step, we will sketch the graph, right? Step number 8 is sketch the graph. We first begin the asymptote, okay? Okay, so we got the horizontal asymptote is y equal to 2, so let's label it. And also we draw the dashed line. And vertical asymptote is x equal to 1 and x equal to negative 1. Okay, and then we will plug in the intercept, which is 0, 0 right here. And this is the point of the maximum, local maximum also. So we only have one point. And then to connect this, before that we'll go back and look at the vertical asymptote. So the vertical asymptote, when we have, let's look at the negative 1, okay? So we have negative 1 in here. So on the left side is up. On the left side of negative 1. So this is negative 1. Left side is here, okay? So we will have like this. It's approach, but it's approach positive. And then we have on the right side of negative 1 is approach down like this, because it's negative infinity. Okay, so then we look at the positive 1. On the right side of positive 1 is positive. So this is the right side. Right side is here, okay? And then left side is negative. So now you can connect this point, and then you can make like this. Because this is the local max, right? Okay. And also, let's double check the information for the concave. So we got the concave down. That means like sad face from negative 1 to 1. So that is matching with what we draw right here. And then we have concave up from 1 to infinity and from negative 1 to infinity. Since we have the two pin approach like this, so we can draw like this, because this have to approach to the horizontal and the vertical asymptote. The same thing for the other side. Okay, I mean the graph, if you want to be more exact, you can make some points, additional points, if you want. Yeah, so you can make like 2, 3, or negative 2, negative 3. Okay, and then you will have a nice, better idea for the graph. But this is good enough. We are just do approximation. We don't do exactly how the graph will pass into what point and so on.